The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Welcome to today's webinar called Best Practices for Apache Ignite Disaster Recovery and High Availability. We will be recording today's webinar, and we'll send a link to the recording as well as a link to the slides from today's webinar shortly after the close of the webinar today. If you have any questions, please enter them in the chat or in the questions window of GoToWebinar, and we'll answer as many as we can at the end of the presentation. I'd now like to introduce today's speaker, Stan.
Hi everyone. Hi everyone. My name is Stan Lukyanov. I work in customer solutions team at GridGain, and today I would like to talk with you about disaster recovery and high availability options that are available in Apache Ignite and GridGain ecosystem. So in customer solutions team at GridGain, we help our customers, users of Apache Ignite and GridGain, to build and maintain their clusters. And obviously, the question of high availability is especially treated by many of them. So we've built up quite a lot of experience with these options, and I would like to share some of that with you today. So what are we going to talk about today? First, we will review what is disaster recovery about, what type of disaster recovery we are going to cover, and what are the different parameters that may be changing depending on your disaster recovery solution, and how can we compare different solutions. Then, after we have these instruments to compare the options, we will review several options that are available for Apache Ignite and GridGain clusters. And finally, we will review all of them once again and see how can we choose between them and what rules to follow. So first, what is disaster recovery and what kind of disaster recovery we are going to talk about today? So in general, disaster recovery is any sort of measures, any sort of plan that you might have in a situation like this. Your application is connected to your system, say it's a GridGain cluster, and the system is not available. For example, data center in which this system is located crashes or loses power or anything like that. So in this case, we want to restore ability to provide the service to our applications and to our users as quickly as possible with as less consequences as possible. And it may mean a lot of things. Disaster recovery. It may mean ability to restart quickly or something like that, but in general, the most effective way would be to have two data centers. So we are talking about the recovery after losing a data center here. So to recover from that, we need a second reserve data center, and we need an ability to switch to it in case the primary data center dies. And for that, obviously, we can just do it. We need some mechanisms, and these mechanisms can be split into two parts. First is the cluster switchover mechanism. This part allows you to switch from primary data center to secondary data center when something happens on primary, or if you just need to go for maintenance or something like that. And the second part is a data replication link. If we switch to secondary data center, but it does not have any of our data, then it's of no use. We can't continue the service anyway. So we need some way to deliver data from our primary system to secondary, or from one data center to another continuously. So these two parts, these two mechanisms will be the components of our disaster recovery solutions. And what we are going to talk about today does not always provide both of them. First of all, we are going to talk about how we do the data replication part, because this is the crucial part. We need to keep our data, we can't lose it. The cluster switchover part, it may be a part of the solution we are talking about, or it may be implemented in a custom way, customized for your application. So some options will have that out of the box, some don't. So after establishing that, let's talk about how we are going to compare the solutions, the disaster recovery options that we will be reviewing. First of all, we need to look at what are the consequences of the disaster if it happens. First consequence is, of course, the service being down, applications not able to serve our users. And second of all, there is a possibility of data loss. So the amount of time for which the service is down and the amount of lost data are the two key parameters that describe any disaster recovery solution or plan. And also there are like auxiliary parameters that are the cost of the solution, the steps we need to take to implement it, the additional software or hardware we need to maintain it, and possibly additional benefits which we get by implementing the solution. So these four things would be what we are looking at to compare our options. Next, let's talk about them in a bit more detail. So let's talk about how a disaster happens. So this is our timeline, and in the middle, something disastrous has happened. And ideally, our timeline, our service timeline would be something like this. Everything was okay before the disaster, everything is okay after the disaster. We just didn't really see it. Our users were not impacted by it. In real life, obviously, this is not always true. First of all, you may, again, lose service for some time after the disaster, and even after you have restored your service back to normal, you may observe some amount of data lost, and normally it would be the last updates that happened right before the disaster. And these two time spans would define our two key parameters, which are called recovery point objective, or RPO, and recovery time objective, or RTO. So these two parameters will be the key to define the quality of our solution. So let's talk about them in a bit more detail. First, recovery point objective. So recovery point objective is the maximum amount of time for which the data can be lost. And I want to stress that this is not just a parameter of your own plan, but most often this is a requirement, the external requirement for your system and for your disaster recovery plan. Your business, users, your regulations may require you to provide a certain RPO. So by this requirement, you will see that some solutions for disaster recovery can be used, and some just cannot because they don't meet the required RPO. And RPO normally would be defined by the replication lag. You remember we will be replicating the data from one data center to another, and this lag for which the data needs to be transferred from one data center to another will define our RPO. And what is RPO of 0? RPO of 0 means no replication lag, means synchronous writes to both data centers from the application. RTO, or recovery time objective. This is the maximum allowed service interruption time, the maximum allowed time for which service may be down. And this is again an external requirement more than just a parameter of your own system. So RTO of 0 would mean that we have some reserve system which can accept application requests. In other words, it's in a standby mode, and our clients or applications can switch from primary system to secondary in an instant. In real life, this is not really true, because and in real life you would rather see one of these. Either you have a second cluster in a standby mode, it is up and running and ready to accept requests at any given time, and in that case, the time client needs to detect a failure of your primary system, the client reaction time or failure detection time, will define the RTO, and this usually is measured in some seconds. And if we don't have a standby system to back us up, then we need to start it first, and it can take minutes or even hours. So this are basically our two options for RTO. It will be either seconds or minutes. But for simplicity going forward, we'll say RTO 0, but by saying RTO equals 0, we actually mean that it's some amount of seconds, some minimal amount of client reaction time. So these are our parameters for comparing our disaster recovery options. RPO changing from 0 to hours, RTO changing from kind of 0, not really, but very minimal time, to hours. And we also will have some cost and additional benefits, and the minimal cost is having a second data center. We can work around it if we want to survive a crash of one data center, and also some way to implement cluster switchover and data replication. So let's look at the options that we have now. First, let's review our basic architecture diagram again. And here we will mostly be thinking about how can we fill the part for data replication, and sometimes also for cluster switchover. How can we remove these two unknowns from the diagram? And the first type of DR solution that is really the easiest one one can imagine, I think, is backup-based disaster recovery. So this is nothing new really. We take backups continuously from our primary data center. We save the data to some external disk storage, which is not stored on our primary data center normally, and we restore the backup on the secondary system, either in case of a disaster on primary or continuously on a standby system on the secondary DC. Obviously, in the first case, we will have worse RTO, and in the second case, RTO will be minimal. What about cluster switchover? Well, backup solutions don't really interact with applications themselves. So a backup solution would not give you a cluster switchover, and the cluster switchover will need to be implemented manually and in a custom way for your systems and applications. So let's review our parameters of these options. First, RPO. RPO will be defined by the period of taking a backup of the primary system, and normally it would be hours. Really, it's not likely that you will be able to take backups more often than, say, every once in an hour or every once in half an hour at least, something like that. So it's a matter of hours. RTO would be, it can be 0 if we continuously restore backups on a standby cluster, or it can be minutes if we don't have a second cluster up and running, but we only restore our backups in case of a disaster on the primary system. So obviously, this solution, the cost of this solution would be having some way to take backups and maintaining a disk storage, and also implementing a custom cluster switchover. We are not talking about implementing that manually today that much, but mostly it will be either an intelligent data access layer, or it can be just restarting your applications with a configuration allowing them to connect to your backup system. And as an additional benefits, well, we are getting backups, and everyone would like backups if they store anything of value, really. And backups are useful not just for disaster recovery, but also for record keeping or for testing and development, when you can take a snapshot of your production data and play with it. And in GridGain, what can GridGain offer in this case? Unfortunately, there is no solution for backups right in the Apache Ignite, but there is in GridGain, and this is GridGain Snapshots. GridGain Snapshots allow you to create backups of a leaf cluster. You don't need to stop it or stop updates on it. Everything happens concurrently with your application load, so no service disruption. There are full snapshots, which take all of your data, dump it on disk, and incremental snapshots, which only take the difference between your last snapshot and the current state. And incremental snapshots are more efficient, faster to create, they take less space, and because of that, you can take them more frequently, achieving better RPO value, parameter. There is tooling for backup management, which also allows automatic backups on schedule, and point-in-time recovery. Point-in-time recovery feature allows you to restore your system not just on one snapshot state or another, but on any state in between two snapshots, and GridGain uses write-ahead log for that. Today, snapshots in GridGain only works when native persistence is enabled. But if you want to take snapshots, backups of your data, it is very likely that you need to enable native persistence anyway, just for safety and data durability. And GridGain snapshots are available in GridGain Ultimate Edition. So this was our first option, and some of you may say that, well, there is nothing new, backups were there for that many decades, and this is true. But then our next option that we are going to review is what is really unique for distributed systems, and this is an ability to have a stretched cluster. So what is a stretched cluster? A stretched cluster is a cluster that combines nodes that run in two data centers at once. So applications talk to the cluster as if it was a single system. It is in fact a single system, so applications don't really care which nodes are in which data centers. They just work with a whole cluster together. And the diagram looks really great because we don't have any unknowns. Now we don't have this cluster switchover because it is just something that, example, GridGain gives you natively. It is just a normal, it would be just a normal failover inside a single cluster, and data replication in a cluster from primary nodes to backup nodes is obviously something that works out of the box. But in fact, this solution requires a bunch of other additional components, and they are on this slide. So first of all, you require a very fast and reliable network between your data centers. Your cluster is only as fast and as stable as your network between your nodes. And if you have nodes into data centers, well, the network between them needs to be as good as it actually gets. So this is the first requirement for this solution. But even if your network is very low latency and very reliable, in fact, you still may have issues if you have a network that is going through through a city, for example. Then you may still see network interruptions. And in that case, you need something which is called split brain protection. And split brain is really a disastrous event that may happen to a distributed system, and I will explain it in more details shortly. And finally, you need your cluster to be actually aware of that it is running into data centers, because it needs to split the data, to distribute the data evenly between the data centers, so that when you lose one data center, you still have all copies of all of your data, of all parts of your data. So we will talk about split brain and data center awareness in detail in a bit, but first let's again review the parameters of this option. So RPO and RTO are really great. They are 0 as all writes can be synchronous in a single cluster, and failover is as fast as it gets when you have a single cluster. All your applications are really connected to all of your nodes essentially. This solution doesn't require the components that are normally required, which are cluster switchover and replication solution, because they come for free, but you have these free components, the network, the data center awareness, and split brain protection, which you need to provide. So let's talk about, we can't really do much about the network, but let's talk about split brain protection and data center awareness. So what is a split brain? Say you have multiple applications working with your stretched cluster, and the network between your data centers dies. Because your nodes are still up and running for each data center, it appears as if the other data center has died. So each data center forms a cluster of its own. So you now have two segmented clusters, and your applications split. Some are connected to one of your segmented clusters, and some connected to the other segmented cluster. And this is a split brain right there. In this situation, you will see that you lose data consistency because different applications independently update your data in two independent clusters. So in a short time, you will see that your data is inconsistent and it will be really, really hard to merge it all back. And this is really the point of split brain protection. Split brain protection mechanism is something that needs to prevent updates on one of the segmented parts and eventually stop one of the segmented parts so that your applications can switch from that stopped part to the only one that is kept alive. So what can GridGain and Apache Ignite offer for split brain protection? This is the whole giant topic of discussion, really. So I won't be able to cover this in detail on today's webinar, but I can just outline the solutions that we have in our ecosystem for split brain. First is a combination of topology validator and segmentation resolver, which are, when combined, both prevents updates in one of the segmented parts and eventually stop the segmented part, avoiding the disastrous consequences of a split brain. And topology validator is part of Apache Ignite, but segmentation resolver is part of GridGain Enterprise Edition. Another solution that you may use is using Zookeeper. You may know that Apache Ignite has Zookeeper discovery option, which means that Apache Ignite cluster will use Zookeeper discovery for keeping the cluster together and maintaining the connectivity. And in that case, we are moving the responsibility to keep the cluster together from our own cluster and our own systems to Zookeeper, which works really great, but the cost of it is, well, maintaining a Zookeeper installation, which will work with your Apache Ignite or GridGain cluster. So the next part is data center awareness and what it is. So let me illustrate. Say you have your stretched cluster and you have data entry A and data entry B, each stored in 2 copies. And by default, your data may distribute in a way that both copies of A are stored in primary data center and both copies of B are stored in the secondary data center. Obviously, if we lose primary data center or first data center, then we don't have any copies of A anymore. So in that case, we have data loss and we can't serve our clients anymore that need the A entry. So to avoid this situation, we have data center awareness, which is a mechanism that makes sure that if we have one copy of A in first data center, then the second copy will be placed in the second data center. So if we lose one of the data centers, we still have copies of all of our entries, and this is all. And in Apache Ignite and GridGain, we actually have a a pretty easy way of enabling that by property that is called affinity backup filter, and this is something that is pretty easy to show. So let's look at a bit of a code here. So there are just 3 simple steps for implementing data center awareness. First, you need to implement the affinity backup filter, and this is some code that you need to write on your own, but your code will most likely be very similar or even the same as the ones you can see on the slide. So what this code does, it reads some property from your nodes, which is called DC, which will be a custom property that we are going to define next. And this property shows which data center we are running in, and the filter just makes sure that our primary node and our backup node will not be running in the same data center, will not have the same DC attribute set. Step 2, we just need to configure the DC filters that we just implemented. We just need to configure it in our caches, and we need to repeat this configuration for all of our caches that we want to be disaster recovery enabled, which we want to be data center aware. And finally, we need to assign the DC attribute values. On each node of the data center 1, we need to assign DC1 attribute, like just one value attribute. It can be any value really. And we need to assign another value of that in the second data center. And that's all. These 3 simple steps make sure that our caches are data center aware and that our data will be distributed between both of our data centers. So this was, we talked about backup-based DR and stretched cluster. So now let's talk about the next option, and this is a continuous streaming of changes between our systems, which may be also called a type of change data capture, CDC. So with streaming solution, we have some sort of streaming processor, streaming connection between our data centers, and there are different options for this streaming, and we will review 2 of them shortly. And for cluster switchover, unfortunately, same as with backup solutions, there are no there is no cluster switchover available just by setting up the streaming. So cluster switchover still needs to be implemented manually. So before we review the actual options for streaming with Apache Ignite and GridGain, let's first talk about our parameters, RPO and RTO. So RPO would normally be of seconds, which would be the asynchronous replication lag, the streaming lag. And it could be 0 in theory if you set up replication synchronously, and you can do it somehow, but this also might be a bad idea because synchronous replication would require a fast and reliable network from you again. And if you have a fast and reliable network, maybe you can opt for a stretched cluster, which is a simpler solution, which does not require the cluster switch or additional cluster switchover mechanism and anything additionally really if you have that good network. And RTO is 0 here. It's simple. We have a standby system which is receiving the data being streamed, And obviously this requires some way of doing streaming or change data capture for your system. And with GridGain, the first option I would like to talk about for streaming is data center replication. So data center replication is a feature of GridGain Enterprise, which allows you to perform change data capture and streaming from one GridGain cluster to another without any additional software. It is just your two clusters connected with a replication link. It can be active passive replication or active replication. We are not talking about active options today. Active means that your replica, your second cluster, is also receiving updates, and like both of your clusters write to each other at the same time. We are not talking about this in detail today, but this is also an option and a requirement in some architectures. The GridGain data center replication allows for complex cluster topologies, including up to 32 data centers. So you may connect more than two data centers. They may be connected in a chain or interconnected, each connected to each other, or in any other complex topology. And as I've said, this is a part of GridGain Enterprise Edition, and the docs are available on the site, but the basic configuration which allows you to set up a basic replication link between two data centers is very easy. So let's just review it real quick. So there are just 4 steps for that. Step 1, we need to configure the caches on the sender side or on our primary cluster side. We need to configure our caches to include this DR sender configuration. This has a bunch of parameters, but for the basic case, we just need to set it to any non-null value so that that cache will be attempted to be replicated. Step 2 is configuring a sender hub. A sender hub is a node. It can be a dedicated node or an existing node in your primary data center, which is responsible for collecting updates from all other nodes and sending the updates to the replica, to the secondary data center. And here we specify data center, our primary data center ID, in this case 1, and we specify the ID of the data center we are replicating, in this case 2, and the address of the receiver node, which we are going to set up later. Step 3 is configuring the caches on the receiver side. So on the sender side, we have configured caches with DR sender configuration being not null, and for receiver side, we just need to set DR receiver enabled to true, which means that this cache will be accepting some updates from another cluster. And finally, we need to set up a receiver hub. Same as sender hub is a node on the primary cluster which sends the updates. Receiver hub is a node on the secondary cluster which receives the updates. And receiver hub also has a data center ID and local address specified as a host and port, which we have specified on the sender as well previously. So this is the first option. So these 4 simple steps allow you to set up a replication link, which is enough for replication part of your DR, but in some cases you may want more flexibility, and in that case you may want to go for Kafka. GridGain Enterprise, and this is a GridGain Enterprise again, comes with a certified Kafka connector, which is certified by Confluent, the primary developer of Kafka. They helped us to develop and test our own GridGain Kafka connector, which can read data, read updates from GridGain and write it to Kafka, or read data from Kafka and write that data to GridGain. So by specifying, by setting up a Kafka instance and Kafka connectors on primary side and on secondary side, we can create that replication link, that streaming link that we need for our DR solution. So obviously this requires a Kafka instance compared to, say, data center replication. We also need Kafka instance, but for that, for setting it up, we achieve even more flexibility. By that, I mean, for example, that you may want to have not just your secondary cluster be your data receiver, but you may also have heterogeneous consumers, and you may have different systems receiving updates from your primary GridGain cluster and acting on these updates. And this is a solution that is available in Enterprise Edition, and in our documentation there is a detailed, although longer, guide to set up data replication into GridGain clusters using Kafka and GridGain Kafka connector. So the next option I want to talk about briefly is system level replication. And what I mean by that is a virtualized system. So say we have application which is connected to a single virtualized cluster running on a virtualization software layer, which can be either a virtualization stack like VMware or VirtualBox, or it can be a cloud provider or a public cloud or private on-premises cloud, anything like that. And that software may allow you to run on several sets of hardware simultaneously, so that your single application is backed by multiple sets of hardware in different data centers, so that even if you lose one data center, you will still not lose your data, or not all of your data, and you will be able to recover your system either immediately or after some time. And all of these parameters depend entirely on the actual virtualization software or providers that you are running with. So the options here would be RTO can be different depending on the vendor and on the solution. It can vary from 0 RPO to RPO of minutes. Normally, from what I've seen, RPO can be 0 if your virtualization is running on 2 data centers which are close to each other and have good latency between them, under up to several milliseconds. If your latency is higher, then it's likely that your software will not be able to provide 0 RPO, but will be able to provide some seconds or minutes. For RTO, the RTO would usually be minutes, because losing, say you're running on a public cloud and your public cloud provider loses a data center. Yes, your data may be replicated on disks, but your memory of your processes is likely to be not replicated. So you still need to restart your processes, and it means potentially some amount of downtime to restart all or some of the processes in your cluster. And obviously for the cost, this means that you are running in a virtualized environment, which can be both costly and hard for your operations team. In this case, essentially, we are moving all the responsibility for disaster recovery plan from our application developers and from our middleware maintainers, from our maintainers of our GridGain or Apache Ignite clusters, to our operations teams who provide us with VMs or with cloud instances. And the final option I want to talk about briefly again is application level replication. What it means is it's real easy. Our application is doing all of the work, or code near the application is doing all of the work. So between our app and our data centers, our clusters, there is an intelligent data access layer, which serves as a both replication vehicle and cluster switchover mechanism. So normally this layer would allow you to write to both data centers at the same time synchronously, and in case one of them becomes unavailable, it just falls back to working with the remaining data center only. So in this case, RPO and RTO are, of course, great because your writes are synchronous to both data centers, and your applications are always connected to both data centers, so they can react as quickly as possible. But this is a full do-it-yourself solution, so this moves all the burden for disaster recovery from your operations, from your vendors of your middleware and hardware and cloud to your actual developers. So these are all of the options, all of the disaster recovery solutions that I wanted to talk about today. So now let's review them quickly and look at how we can choose between them and how can we navigate between these options. These are all 6 options that we talked about: backup-based solutions, stretched cluster, 2 streaming options, which are GridGain Data Center Replication and GridGain Kafka Connector, and also system level and application level replication. So backup-based has relaxed RPO, but is easy and gives you backups, which is great. Stretched cluster has really great parameters, but requires a lot from the in terms of network and system stability and some additional configuration in the cluster to make it safe. Streaming options are a good middle ground, and data center replication is great as it works out of the box, while Kafka Connector allows even more flexibility, such as having heterogeneous consumers. And system level replication is costly for your operations and can be costly as a solution, but easy on your application developers and cluster maintainers. And application level replication is, well, moving all the costs to your development teams. So how can we choose between all of that now that we know what we compare? So first of all, by default, I would say that GridGain data center replication would be the fit. Why? Because it works without any additional components, without additional software, and if you need to just connect two clusters so that one can serve as a secondary replica for disaster recovery, this is likely to be the choice. If you have very low RPO requirements and hours for RPO is not a usual requirement, but if you can allow that, for example, if you can lose some of the data, or if you have the data for last several hours stored in your upstream system and which can be replayed, then you can go with GridGain snapshots for backup-based solution. Simple, powerful, provides you with backups for record keeping and for testing and development use. If you are not satisfied with data center replication because of the some limitations, or because you want to have heterogeneous setup, then you can go with Kafka. It is real flexible and also allows you to set up the streaming between your two data centers. And finally, if you are already running in a virtualized environment, such as a virtualization stack or on private cloud or public cloud, check out what are the guarantees that your vendor or your platform provide you, because the chances are good that they already provide the RPO and RTO that meet your requirements and that you can use. But if they don't, or if you're not running in a virtualized environment just yet, then maybe going for virtualization or cloud just for the sake of disaster recovery. It might not be worse for you just because it is usually costly and other options may provide you same value for better cost. Thanks for your attention. This is all, and now I'm ready to take the questions.
Okay, hello everyone. If you have any questions, please input them in the questions tab and go to webinar now. We'll give you just a minute here to see if we have any questions, and if not, we'll wrap up the webinar.
Yeah, and while we are waiting for the questions, let me go over the resources that we have that may help you with when working on Apache Ignite and GridGain. First, it's Apache Ignite community resources, the public documentation, the mailing list, and the Stack Overflow. Go check them out, and feel free to ask anything there if you have any questions about Apache Ignite. There are also a bunch of GridGain resources. First of all, we are running these best practices for Apache Ignite and GridGain production webinar series. So you can check out our past webinars and make sure to check GridGain website for new ones. And also you can check GridGain forums for GridGain and Apache Ignite questions, or GridGain documentation. And also feel free, if you have any questions, feel free to contact me directly. The emails are on this slide.
I'll also point out for those of you who have access to the Bay Area, the In-Memory Computing Summit will be November 13th and 14th at the Hyatt San Francisco Airport. And there'll be a number of talks there about Apache Ignite, as well as many other in-memory computing technologies from users and vendors. There'll be some links to that in the follow-up email from today's webinar. So if you're interested, please take a look. We are holding a raffle to give away a limited number of free tickets as well. If you'd like to enter the raffle, there'll be a link there. So Stan, we have a question. It says, can the backup policy be applied if I don't have the persistent option enabled?
Unfortunately, not yet. In the GridGain snapshots that we have in GridGain Ultimate are based on our native on Ignite native persistence. So this is only for persistent enabled caches.
Okay, very good. I think that's the only question I see. There will be, as I mentioned, a follow-up email with a link to the recording as well as to the slides from today's presentation and further information on some of the resources that you can use. Please watch for it here within the next 24 hours. Thanks everyone for attending our webinar, and thanks Stan for presenting. Have a good day.
Thanks everyone. Thanks Terry. Bye-bye.